Hello everyone, welcome to our final research project presentation and demonstration about digital media steganography in cybersecurity. My name is David and other team members are William, Morris and Eric with the guidance from our supervisor Dr. Huang Ding, a senior lecturer at UTS, today to present you our research findings. Here is our presentation content. We will briefly discuss what steganography is, its history and background, the differences between steganography and cryptography, the different types of digital media steganography with demonstrations, and a conclusion of overall findings and future works. Please feel free to pause the video at any time if it's too fast.
What is steganography? Steganography is an art and science of hiding the extent of security information. As we know, information security is an essential challenge in the open network environment, which has given rise to many approaches for security systems, such as information encryption and information hiding. The steganography developed an invisible way of communicating who is hid the security information behind other data by common digital media.
So history and background. The term steganography could be traced back to ancient Greece. In ancient culture, steganos stands for covered, while graphy means writing. The original format of steganography is tattoo secret message on people's head and shave hair to receive message. Other formats are using wax tablet, invisible ink, etc. And modern steganography arose in around 1985 when personal computers became popular.
Steganography versus cryptography. Steganography and cryptography are the two security mechanisms that exploited distinctly in the field of information security. They protect data in different ways but for the same purpose. As I mentioned before, steganography is a technique of information hiding and cryptography is a technique of information encryption. What do they take to apply the algorithm? For cryptography, the original data is communicated in ciphertext. Sender uses one key to encrypt it, and the receiver must use another key to decrypt it. Depending on plain text is encrypted by what algorithms. For steganography, the inbound algorithm will hide secret data into cover data, with the optional key to get the signal object containing the secret data. If you want to decrypt the signal object, must know what algorithm it is using and know how to reverse it. In short, steganography is a technique to hide the extent of communication and dropping the secret message itself, so steganography's data is always invisible. Cryptography is a technique to protect data communications. It uses keys to lock secret information and cannot be unlocked unless using the key. So cryptography's data is always visible.
There are 5 different types of media steganography, such as text, image, video, audio, and network.
Text steganography is a mechanism that hides a secret text message in other text from a covering message or generates a cover message associated with the original secret message. Hiding text can involve anything from changing the formatting of existing text, changing words in the text, generating random strings of characters, or using grammar without contextualized to produce readable text. Steganography of text is considered the most delicate because of the lack of redundant information when compared to an image, audio, or video file. There are 3 major categories used to hide text messages: format-based, random and statistical creation, and linguistic method, which will be further explained in the next slide. There are 4 text steganography techniques. Format-based method uses special characters such as spaces to alter the spaces between words, lines, and paragraphs. Random and statistical creation method uses automation to create cover messages without any prior cover messages and utilizes algorithm to add more complexity to create an entire paragraph. Linguistic method, on the other hand, makes use of punctuation marks such as commas, periods, and many more on the cover text to hide the secret text. The use of punctuation marks are used as an identifier for the secret text. Semantic method uses an algorithmic structure to create synonyms for each and every word to keep the secret message hidden. Now we're going to talk about text steganography techniques in comparison. As we have previously mentioned before, there are 4 steganography techniques. And now we're going to talk about advantages and disadvantages. Format-based method is very hard to notice from a casual user's perspective. However, word processors can inadvertently affect the number of spaces. therefore revealing the hidden data. For random and statistical creation method, it does not require an existing cover message, as it can automatically create its own cover message, and it can also utilize the secret message to create the cover message. However, it takes a longer time to insert and extract the secret message from the cover message. As for the linguistic method, it uses punctuations to hide the secret message and as an identifier for the hidden text. However, the size of data changes based on the number of punctuations used in the cover message, therefore affecting the size of the data, which can also mean that IT professionals could easily discover this just by checking how much megabyte it has used to hide the secret message. As for the semantic method, it cannot be detected by retyping or using an optical character recognition program, OCR. And as for the disadvantage, knowledgeable readers who have a wide range of vocabulary can easily discover the hidden message, as semantic method utilizes synonyms for every word so as to hide the secret message. White-space text steganography is a technique from the format-based method that utilizes TextNo as a program for hiding messages in text files by adding tabs and spaces to lines, and extracting methods from files that contain hidden messages. Tabs and spaces are mostly invisible to text viewers, which is the nature of this encoding schematic. By adding a sequence of up to 7 spaces, the data is then hidden in the text file and interspersed with tabs. This generally allows 3 bits to be stored in every 8 columns. TextNo provides basic compression with the use of Huffman tables optimized for English text. Encryption is also provided using the ICE encryption algorithm in 1-bit encryption feedback mode. Since the key size of ICE is arbitrary, it supports passwords of any length up to 1170 characters because each character only uses 7 bits and supports keys up to 1024 bytes. If a message string or file is specified on the command line, TextNo will try to hide the message in the archive file. Otherwise, it will be hidden in the standard input. If specified, the generated file will be written to the output file. Otherwise, it will be written to standard output. If no message string is provided, TextNo will try to extract the message from the input file. The result is written to the output file or to standard output. And now I'll be doing the demonstration for TextNo, which is whitespace steganography. As I've already installed Ubuntu and TextNo, I will now begin with the demonstration. I'll start off with creating a source text, and then I'll utilize a random text generator to copy and paste into this, which I'll then enter, Control D. So after I'm done with this, you can see that if I just write cat.source.txt, I can see the actual text. Now I'll clear it, which then I'll start beginning the process of compressing the hidden message inside the paragraph, which I'll begin with TextNo-c compression -m, which is the message string, which then I'll type in pineapple pizza is good. And then I'll type the destination, which is source.txt, and what the text will be known as, the hidden message will be known as hidden.txt. From then on, if a casual user, obviously just do cat then source.txt, you just see this. However, if you do this TextNo-c, which is to obviously extract the hidden message, and then write hidden.txt, you can see the hidden message. And that will be the conclusion for my demonstration.
Image steganography is the one of branches of steganography, and it is usually to hide information without destroying its confidentiality, integrity, and availability. It aiming to disguise the high value of its communication content. Image steganography techniques include the least significant base image, minimal noise tool, edge-based image, pixel value difference, and grid level modification. Iris-based image requires converting the pixel values of RGB of the target hidden image and cover image to binary and replacing the least significant bit of the latter with the former. Minimal net store is an algorithm that scrambles images into array and encrypts them based on edge and LSB pixel replacement steganography. Edge-based image is a technique that has secret message in the edge of cover image. Pixel value difference shows that the difference value between two neighboring pixels is used to decide how many secret bits should be inbounded. Grid-level modification presents an efficient method for RGB images based on grid-level modification and multiply-level encryption. This is a comparison table listing the pros and cons of all image steganography techniques. The next session will briefly cover this significant bit background and principle. After that, we'll do the demonstration. For steganography, images being the most common steganography carriers. LSB image steganography is the traditional technique used as an image steganography cornerstone to hide secret information in cover images without causing obvious artifacts. As we know, the pixel is the smallest unit in an image, which holds an element's color value and brightness value at a particular position. A picture is displayed when the pixels become a matrix containing a fixed number of rows and columns. Computers use red, green, and blue monochromatic images to generate a color picture that we can perceive. For RSB, the principle is that one binary pixel's value will be an 8-bit number. The first 4 bits are the most significant bits, and the 4 last bits are the least significant bits. When you change a least significant bit, it is not noticeable at all, so you can change multiply pixels least significant bits to carry binary information. In the demonstration, I will use 4-bit RSB. Hello, this is the image steganography of least significant bit image techniques demonstration video. In this demonstration, I will use the Ubuntu on virtual machine to run the program, and I will introduce how to encrypt the secret image or message into cover image and show how to decrypt them. In the end, I will display how to detect the extent of secret image. So first of all, let's show the source code which is come from the GitHub. Here, this session is for encrypt the secret image to the Steganography image by 4 bits least significant bit. And in this session is for decrypt the Steganography image to secret image by force reverse the 4-bit LS bit. Now let's start the demonstration. Here, there are 3 images and 1 text to display the LS bit technique effect. Now I will hide the boy.png into snow.png. So for this command, the first one is the cover image, and the second one is the secret image which you want to hide. Now we get the signal image, and let's comparing them. So for a good signal image, the most important thing is we can't find any artifact in the signal image, because if we find any different here, the steganography will be failed. As a contrast, let's try to use the forest to hide the boy.png. So first one is current forest. Oh, sorry. Because of the features of 4-bit LSB, if we want to hide a complex secret image, the cover image needs to contain more lines and signs. Like the forest, it will get better effect when used as a cover image. Let's see the result. See, it works very well. Definitely, we can't see any difference in these 2 images. So let's move to next part. Hide the text into image. So this is the source code, which is same as the image 1. So we have a key.txt here is including 1 sentence. This is a secret message. I will hide this file into snow.png. So first one is the cover image, and we will use snow.png and k.txt. Done. Get the Steganography image and comparing it with the cover image. So you can see any difference. So this is success. Simply, if we want to decrypt the Steganography image, just type the comment like this. So here we want to decrypt the merger.png, so we just put here, which is this step. Done. We decrypt them, and it's same with the secret image. So what about the text? So let's put the snow pattern. So this one is carry out the secret message. Done. We found the hidden message. This is the secret message. Same. Finally, we can use the program to detect the extent of secret image. So let's just use this Steganography image and move to here. Paste. And we will using this command. This one. So here the I is it means the input path for the image, and then N it means count to how many area space you want to display. The default one is 2, but we are using 4 bits area space, so now we'll change it to 4. Let's try. See, succeed. We succeed find the hidden image from the Steganography image.
Video steganography is a combination of image and audio steganography. So they have a lot of techniques such as substitution-based technique, transform domain technique, adaptive technique, format-based technique, and cover generation technique. Substitution-based techniques such as least significant bit, pixel value differencing, bit plane complexity segmentation aims to replace redundant data from the cover object with secret messages. In transform domain techniques, cover objects is transformed in the frequency domain. Secret data is hidden in the transformed coefficients. Then reformed coefficients are sent back to the original form of the cover objects. Adaptive techniques, also known as masking, it studies the statistical features of the cover object before the hiding process. This aims at identifying the best regions to embed information. Format-based techniques are steganographic techniques produced for particular video formats, while in cover generation technique, objects will be synthesized and used as cover video. Each technique has their unique features. The table presented below summarizes their respective advantages and disadvantages, which has been deeply discussed in the report. Now I'm going to introduce you video steganography using Hamming code 74 algorithm. Hamming code is a famous block code method which could perform error detection and correction on a data block. Original information will be coded by adding some extra data with the minimum amount of redundancy. So in this algorithm, the message of length k bits is encoded by adding 3 parity bits to become the code word of length n before the transmission. So we use k equals to 4 and n equals to 7. That's why we call it 7-4. This algorithm contains data embedding stage and data extracting stage. This figure illustrates the embedding process. So at first, we need to convert the video streams into frames and then separate each frames into Y, U, and V components. By the way, white UV color model is what camera captures and what human views. Then we can change the position of our pixels in 3 components by a special key, then convert the message to a one-dimensional array, change the position of the whole message by a key. Next, we can encode each 4 bits of the message using Hamming code encoder. The result of the encoded data, which consists of 7 bits, is XORed with the 7 bits of random value using a key. Then we can rebuild the frames and generate the Stego videos. In the data extracting stage, we're going through a similar but reversed process. At first, we still need to convert the video stream into frames. Then we separate each frames into Y, U, and V components. Then we change the position of all pixels values by a special key that was used in the embedding process. Notice we need the same key. Next, we obtain encoding data from the YUV components and XOR with the random number using the same key that we used earlier. And then we can decode the 4 bits of the message by the Hamming decoder. Then reposition the whole message again into the original order, converted the message array to 2 dimension. Then we are able to view the original message. We also have a demonstration video to deeply explain how to embed and extract secret message using Hamming code 74 video steganography technique. The demonstration will further explain the programming codes used to conduct the previous processes.
Now I'm going to demonstrate to you how to implement Hamming code 74 algorithm using MATLAB programming platform. Firstly, we need to specify the name of the cover video in the file main.m and other relevant files. So for the purpose of comparison, we're going to use 2 files, small.mp4 and large.mp4. The small.mp4 is a 5-second video, while the larger one has 27 seconds. So let's have a look at the original video first. Okay. Moreover, we also need to define a key number used for embedding and extracting process in the file main.m. This key is used to reposition pixels in YUV components and the secret messages into a random position. So this key is shared between sender and receiver. So in this case, we'll use key equals to 5. Now we can run the following files in order. The first one is main.m, so we can click run here. So this code will create a folder called frames, which contains the RGB frames of the video small.mp4, as well as scrambled YUV components in separate folders. So we can see a folder called frames have been created. Now inside frames, we have 4 separate folders. Let's take a look at the first one, for example. Next, we can run the file embedded message.m. So the binary image message.png, which is the secret message, will be embedded into the scrambled YUV components. This file also does Hamming code calculations. By the way, notice we have key equals to 5 here, as we defined. This file also does Hamming code calculation, also define a XOR key for XORing the bits of the message matrix. It also includes a embedded key, which is used to pick the random rows in each chaotic YU and V component. Then we have the process of applying Hamming code, calculating the XOR, and finally embedding the message. So by the way, this window pop up. This is the secret message, which is the message.png file. Then we can run combine files.m. Now a new directory named embedded frame RGB is created inside the frame folder. So the embedded RGB frame will be created in this folder. Now we can have a look inside. Okay. Next, we can run the file frame to video. So a video will be created from the embedded RGB frames, and the name of the video is EM video, which has
and format of AVI. Now notice a video has been created and has been saved in this directory. Let's go have a look. So notice that in this video, they have different color compared to the original video, and the audio is somehow missing. So these are defects and should be fixed in future version. Next, run receiver retrieve.m. Now from the video em small AVI, the message will be constructed back and displayed. We can see the extraction process have similar but reversed process that are in the embedding process. So like read video, constructing frames, scrambling frames, and perform Hamming code correction, and finally reposition the message into the original ones. So we notice that in here we have the same key used in the previous section. Notice that we have a folder called receiver embedded frame RGB being created, and also this window pop up. So this picture is the extracted secret message. Okay, so at last we can run psnr.m to check the calculated PSNR value, comparing the original and the retrieved image. Here, so notice that the PSNR value we get using small.mp4 as our cover video is 13.9. Now I have repeated the steps again, but this time I used the large.mp4 file, which has 27 seconds as the cover video. So notice that this time we have more than 800 frames, while last time we only had less than 200 frames. So let's compare the two extracted image with the original image. So it is easy to notice that the quality of the image we extracted using large.mp4 as cover video is closer to the original video, to the original message. Yes, so that's the end of the video steganography demonstration. Thank you for listening.
Audio steganography is a technique of concealing secret data within a cover audio file by exploiting the weakness of human auditory system. There are several audio steganography techniques such as least significant bit coding, parity coding, phase coding, spectrum, echo hiding, and tone insertion. LSB coding method is to replace the least significant bit of data in the cover audio file with each bit from the secret data and output the embedded audio file, or it can be called stego audio. Parity coding is a technique of breaking down signals into separate regions of samples and then encode each bit from the secret data into that sample bit. Phase coding is a method that encodes secret data bits into phase shifts in the phase spectrum of a cover audio file. Spread spectrum, unlike other techniques, is a method of spreading secret data over a wide frequency bandwidth. Echo hiding is a technique of hiding secret data in a cover audio file by introducing an echo into the file. Lastly, tone insertion incorporates low power tones into the proximity of significantly higher tones. Here is a table of audio steganography techniques comparison, the pros and cons of those techniques. Next, we will mainly focus on the LSB coding algorithm and demonstration, which is the most popular technique used in audio steganography. Other techniques, however, will be discussed in future work later. For LSB encoding or embedding, at the center side a cover audio file and a secret message file are being converted into binary bit, and every last significant bit of the cover audio file is replaced by each bit of the secret data. Thus, it results in a stego audio file, which is then transmitted to the receiver through various communication channels. At the receiver side, the least significant bit of the stego audio file is being extracted or decoded in order to obtain the original message and the cover audio file. This figure here illustrates the LSB coding algorithm. This is audio steganography least significant bit coding technique demonstration video. First, let's start with the source code here from GitHub that will be used to perform audio LSB encoding and decoding. So this section of code is to hide secret message into a cover audio file. And this section of code below is to extract the secret message from the stego audio file. And here is the instruction on how to do it. So let's start with the demonstration. I have pre-installed and downloaded the required software to perform this technique already, as well as a sample audio file here for hiding secret data, and also the secret message file here, which contains the word secret. So let's just get started straight away. In order to hide the secret message into the cover audio file, we can follow this command. So it's stego-osb wave stack -h is to hide, -i is to input the audio wave, and then -s is to insert the secret text file, and then -o is to output the stego audio file, and then -n is the number of least significant bit count. So by default it is 2, so we just need 1 bit. Now we get the audio stego file. We can also recover the secret message from the stego audio file by using this command here, stego-osb wave stack -o is to recover, -i is to input the audio stego file, and then the output we can put output.txt, and then -n is the number of least significant bit count, which is 1, -b is the byte hidden, so here is 7 byte hidden, so it's 7. Yeah. Now we get the output file, which is exactly the same as the original message. For further investigation and comparison of the original and stego audio file, I have exported those files onto Windows, and here are the results. We can use the HXD software to view the metadata of those files. In our case, we can view the hexadecimal value and the binary value of those files. So this is the hex value of the audio file, the cover audio file. This is the secret message, which we code as secret. And this is the hex value of the stego audio file. So as we can see that this highlighted part is where the secret message least significant bit has been inserted into the cover audio file. Next, we can use this hexadecimal value to convert into binary value using the online software. However, I have already converted them, and here are the results. So this is the binary value of the original audio file. Here is the binary value of the secret message, which is secret. And here is the binary value of the stego audio file. Then for better visualization, I have manually converted them into this figure for comparison. So this is the binary value that I have copied from the binary converter. This is the binary value of the secret message, and this is the binary value of the stego audio file. As we can see here, that each bit of the secret data has been inserted into the least significant bit of the cover audio file and embedded in that file, which is then output the stego audio file are shown here. We can then also listen to these two audio files to see what's the difference. It is clear that all of the files exactly sounds the same. So we cannot tell the difference by listening to the audio file. Network steganography, on the other hand, also called protocol steganography, is a method of hiding secret information or secret data between senders and receivers by utilizing network protocols. There are over 100 different techniques of network steganography. However, they can be classified into three classes: storage-based, timing-based, and hybrid. Storage-based method is to modify the value in the carrier data, for instance, altering the protocol header to generate a storage-covered channel. On the other hand, timing-based method modifies the timing of activities or event in a carrier to generate a timing channel covered. And finally, the hybrid method is a combination of storage-based and timing-based method. Here is a comparison table of network steganography techniques, the advantages and disadvantages of those methods. Due to time constraint and resource limitation, a demonstration of network steganography is not within our research scope, but it will be discussed later in future work.
In conclusion, all forms of steganography, be it text or video, would require more time and effort to be able to explore the possibilities of various techniques performed in each type of steganography. Network steganography in particular is also required to be expanded upon. Steganography in general has advanced by a huge margin in recent years due to the advent of technology. There are many more prospects of steganography that can be further built upon to review and test the nuances of a variety of techniques and methods. An automation tool for all forms of steganography would be necessary to bypass the challenges faced through choosing specific techniques.
This is the end of our presentation. Thank you for watching.